Good morning once again, and welcome to KSR Data Vision. So, in today's session, we are kind of going to cover why we need SQL, why we need the concepts of SQL to be very much clear for any specific data field. Um, and what all we can do with the help of SQL. I mean, how do we process data? Why SQL is important as compared to, there are many such programming languages apart from SQL, which can be used for database perspective. But why only SQL is more frequently used? The information related to SQL we are going to cover. First 2 or 3 days, most probably we would be covering all the non-technical concepts only. Once we get a good idea why SQL, why database, then only we would be moving towards the coding concepts of the structured query language. That's the SQL which we are going to see. The agenda for today's session is why do we need a database? There are different schemas in database. Now, what do you mean by schema, and what all schemas are present in a specific database that we are going to see? There are different types of databases also. I mean, with the exact use case, we ourselves have to decide what type of database we are going to use. Why and what is SQL? Now, what is database and what is SQL? The exact difference between SQL and database also we are going to see. History of SQL. What's the history? When was it introduced? How it came into picture? How is it occupying the database world or the data related world in today's scenario also? I mean, it was introduced back in 1970s, around 55 years back, but still it's the market leader. It is at the topmost position. Ways of processing the database. There are different ways. Once we connect, once we consume any specific information from the database, there are many ways of processing that database also. And if time permits, we would also be seeing the installation of database today. How do we install any specific database? Now, moving further, let me ask one question. So how many of you are used to with the any anime related movies, or any movies which are most probably more a part of Japanese or Korean series? Anyone used to watch the Korean series or any Japanese series? I see there are many folks who has an interest for anime related series also, the Korean movies also. Okay. Um, so if I try to give certain idea, maybe I'm speaking with you guys in English, it would be very easier for you to understand the way of communication, what I'm trying to communicate. It is very easier to understand. Now, if I try to give some information here, um, so assume this is certain, this is a certain language here. So how many of you get what is written here? I guess the only word which you will be getting here is the SQL. If I try to give certain idea, the only word which you would be getting here is this. Now, I'm speaking with you guys in English, easier to understand. What I'm trying to convey, very easier to grasp also. But if something is written in this manner, and only this is in English, whereas the other, this is something, a Japanese or a Korean orientation, very difficult to understand. Now, if I give you a certain idea, this one, I guess most probably around 70-80% folks would be able to understand. Now, what is this?
Yes,
So the issue is, for any specific database, now even I'm speaking in English, it is easier to understand. The downward, the Devanagari script, the Indian, the Hindi language script, this is also easier to understand. Why? Because we are used to this language, used to English, used to the Indian languages which we speak, the mother tongue which we speak on daily basis. Now, similarly, if you try to compare it with any specific database in the world, there are certain languages. We have to convey database using that language. Now, we assume that there is a database where which the information is stored, accepted, but there is a way of approaching that database. There is a way of connecting that database. Now, that way is we are trying to connect it with the help of certain language, certain programming concept. Now, that programming concept is called as SQL. SQL is nothing but a normal language. You can assume this as a mother tongue of database. Now, there are many different languages which can be used to connect, which can be used to convey the information from the database, to connect, to ask the database also. But SQL is the most widely used programming language to connect, to interact, and to make any specific changes with the database. Now, so why do we need database? Why do we need database? Data is a kind of new fuel, because wherever you go, the way, I mean, wherever you go, the data is increasing on day-to-day basis. We have seen few real-time applications, real-time examples in yesterday's session, where every application which we use on daily basis, the information is generated. If you try to log in any specific application, there your information would be saved in the backend. Now that backend is called as a database. So whichever concept or whichever technology or whichever aspect you see in day-to-day life which we use, there the data is generated. So that's the new fuel. Wherever you go, the data is generating new fuel of the world, but only data is unorganized information. Now you cannot claim that whichever information is stored, that is in completely organized manner. It is stored somewhere, accepted, but it could be in an unorganized manner also. So in order to make that data in a particular organized set, in order to make that specific information which we are trying to save it in the backend in a particular organized manner, we need to use this concept of database. Now, database plays an important role in any specific aspect, or maybe you are a part of data analyst course, but if you are working as a website developer also, if you're working as a front-end developer, for a website developer, you also need to have a database connected to the background. You cannot directly get the information. I mean, if the website is not connected to the any specific information in the background, it is very difficult to get the any you could say, assume that you are trying to connect an Amazon, which is a shopping website, and if there is no information present in Amazon, that means there is no database in the background. Now what is the use of Amazon? You cannot simply go to Amazon and you cannot see any information. What is the exact use? If there is certain products, if there are certain information present in the Amazon, then in that only the usefulness of Amazon is important. I mean, we can go there, we can browse the information, we can shop whichever product we want, we can add it to cart, and we can make the payment. So for every specific application, for every specific real-time the information technology concept, there needs to be a database. Why? Because the information in the background is stored in the database. So not every time the information is organized, we ourselves as a user, as a data analyst, or as a database developer, we have to make sure that the data is organized in a particular format. So for that case, we have to first understand why database is important, what all concepts are there in database, and how do we communicate with the database. Now, second important point is database can store huge and large number of records. Now, it can store minimum number of records, or it can store large number of records. Now, here you will have a confusion that where do we use database and where do we use data warehouse? Now, there are concepts like data warehouse, data mart, data lake. Now, what do you mean by these three concepts, and what is difference between these three concepts and the database? Now, database is nothing but a kind of organized structure of data. And if the data is large, I mean, if we want to dump that data in chunk amount or in large amount, we can move it to a data warehouse also. Now, warehouse is where the data is organized, but data is in very large number. And the way of, I mean, the costing for a database is way more higher, because it is kind of updating on frequent basis, and it can handle few number of records only, the records which are updated on frequent basis. Whereas if you move it to the data warehouse is a kind of historical repository where all your previous data can be dumped. Maybe if you want to analyze that data in the future, you can use that data. Now going further, we're also going to see what is the exact difference between the database, warehouse, data lake, and data mart. But once we get the exact idea of database, then only we can get the use case of the other concepts. Now, database is also a web interface to data. Now, what do you mean by web interface? I've given you certain idea. If you're using any specific website also, there has to be a data present in the background. Now, for web interface, for Amazon, if you take an example, in order to access Amazon, you need to have your account created in the Amazon. You need to have an account. So in order to create an account, you need to have a username and you need to have a password. Now, this is one way of communicating, or this is one way of logging any specific website or any web interface. Now, similarly, in order to access any specific data, we need to have a username, we need to have a password, or else we can log in with the help of authentication and authorization process. Now, authentication and authorization means either we'll get a kind of authentication where many folks might know that there is a Microsoft Authenticator. There's a tool called as Microsoft Authenticator, where a 2-digit or a 4-digit code is shared, and you enter that code, you can log into any specific application. Now, similarly, for a database, there is also a way to communicate with the help of Microsoft Authenticator. Now, I'll keep it as MA, Microsoft Authenticator, and there could be any login credentials also. Once you log in with your username, you can save the password for future references. Now, that is also a kind of permanent authorization process. Now, there are different ways to interact with the database, and that different ways altogether combine to form a complete web interface. Database is a quick and easy to find information. Now, quick and easy to find means whichever information you're trying to search, if it is in organized format, it would be way more easier to understand. Why? Because we know that where the data is residing, because it is everything organized, everything is in filtered format. Now, that is the important point here. It is way more quick. If you store the information in any specific database, it is very quick. Why? Because it is organized and it is easier to find also. Easy to add, edit, and delete. Now, these three play an important role. If you're working on any specific databases, if you're working on any specific backend storing information technologies, these three concepts play an important role. We can add the information. Once you add, there has to be an option to edit, because if you're not able to edit it, what is the use case? The data is changing on frequent basis. Maybe your password might not be same for longer duration. After 30 days, you have to change your password, or you are changing your email ID. You're changing your addresses stored in the Amazon website. You're changing your mobile number. If you are unable to edit it, there is no use case of using any specific database. So it is must that we can edit. We have to have an option called as edit database or edit information present in the database. And the most important factor is we also need to have flexibility to delete the information from any specific database. Once we add, we can also edit it. But the information, if any specific user who was using Amazon for a longer duration from an Indian location, and he has moved out to some different country, he doesn't want to use that Amazon credentials which he have used in India. He wants to close his account. So closing the account means deleting the information from the backend database. So it is most important aspect. Adding is okay because we have to add information, but once we add, we also have to have a flexibility to delete, and we also have to have a flexibility to edit the information. So these three factors play a very vital role for any specific database. We can share and collaborate the data. Okay, we can add, edit, and delete, but there has to be a mechanism that the information needs to be shared with multiple folks. So share and collaborate the data using database whenever required. Important factor, data might change frequently. We have seen here data is a new fuel, but data is changing very frequently. So to make up these changes up to date, the usefulness of database. Why? Because we have seen the important the scenarios here, the features here. Why? Because it is quick. We can add, edit, and delete, easier to find information. We can use a web interface where we can use username, password, or authentication systems, and we can share and collaborate. So these are all factors combined together to give a better database perspective where we can store and interact with any specific information. Now, moving further, there are few examples. Now, few examples means if you are storing some information in the data, it has to be in certain format. You cannot store because the data needs to be organized. Now, organized means assume this as a table. Table is where the information is stored. The database information is stored. Now, somewhere in table, the information is stored in this format. Some horizontal and vertical lines are there. And what this horizontal and vertical lines we are going to see. Data in database is a stored in a table format. Now, table format means structured format. So not every time in a database table, the data is stored in a table format. There are few databases which are also called as NoSQL databases. Now, what do you mean by NoSQL and what do you mean by SQL? At the end of this session, we are going to see, but there are also certain databases which doesn't store information in the tabular format. Now, that is a different way, that is a different concept. At the end of the session, we are going to see what do you mean by difference of SQL and NoSQL. But for now, in any specific database, the information is stored in the table format. Now that specific table is broken into smaller entities. Why? Because easier to find and very fast to interact or very fast to search the information. Now that smaller entities are further called as rows and columns. Now this horizontal entity is called as a row. Whichever information is stored in the horizontal format, this horizontal format from left to right, this is called as a row. And whichever information is stored in the vertical format from up to down, this is called as column. Rows and columns. Now, one who are entering the field of database or data analytics, even in some interviews, they'll ask you what do you mean by row and column and how row and column is stored in the any specific table format of a database. This is an interview question. Might look silly, but this is still asked in interviews. One who are joining as a fresher or one who are new to this field, what do you mean by row? What do you mean by column? And how the information is stored? What do you mean by vertical entities or what do you mean by horizontal entities? They'll not ask you row and column, they'll ask you horizontal and vertical entities. So a record, which is also called as a row, is each individual entry which exists in the horizontal format. Now, for example, there are 10 records in a customer table. Now, 10 records means record 1, record 2, record 3, record 4 till 10. There can be 10 records. Now, this is simply an example. If there are 10 records, now that 10 records are called as 10 different rows, which is stored in a horizontal format. Now, if the information is stored in the horizontal format, there has to be some vertical conversation also. Now that vertical conversation is called as a column. Rows, horizontal, columns, vertical. Now this is an example. Column means this is column 1, C1, C2, C3, C4, and at the last, this is C5. Now, somewhere the information is also stored in the columnar format and the information is also stored in the horizontal format, the vertical as well as horizontal format. Make sure you know the concept of horizontal and vertical very clear here. If it is horizontal, it is called as row. If it is vertical, it is called as column. And both club together to form a complete table format where the information is stored in the database. The way of storing information in any specific database is called as a table format. Now, This is the simple representation, how a table looks like. What do you mean by field? What do you mean by the vertical field, or what do you mean by horizontal row or record? Now, if you take an example, this is simply an example of the instructor table where instructor ID is present, first name, his last name, instructor first name and last name, his address, from which city he belongs to, and which state he belongs to. Now, this information has been taken from a particular table which is stored in a database. Now, this complete entity is called as a table, and every individual vertical aspect, now these are all vertical aspects, these every vertical aspects are called as columns. Instructor ID, first name, last name, address, city and state. Now, whichever information is stored in the horizontal format is called as a row here. Now, there are multiple rows. Multiple rows means usually the information which is present in the horizontal format or rows is specifically to multiple people. Now, here you can see there are multiple instructors. Their names and instructor IDs are present here, individual names and instructor IDs, and what type of information which is, this table is trying to convey. What is this? This is name. This is last name. This is address. So information which gives you more insights is called as a field. I mean, every column is giving you more insight. That is, it is address, that it is city, that it is state. Whereas record is an individual perspective. Row is an individual perspective. Row might have a different information, but what that information is trying to convey, that we can get with the help of columns. The complete table format, how the information is stored in any specific database. Now, moving further, there is a concept called as schemas. What do you mean by schemas in database? Now, a database schema, it's like a skeleton structure. Now, what do you mean by skeleton structure? For every human body, there is a skeleton behind it. Now, behind it in the sense, there is a bone format, there is a skeleton format on which our complete the mass tissues or the complete body mass is dependent on. Now, similarly, for any specific database, there is a background skeleton structure. Now, that skeleton structure is called as a schema. Now, schema, usually it is designed when database doesn't exist. Now, similarly, if you take an example of our human body only, prior to human body, there has to be a skeleton in the background. Skeleton is where our complete body structure is aligned, and on that our complete body mass index or our complete body mass is based on. Now, similarly, for any specific database, wherever we are storing information, there has to be a skeleton structure. Prior creating that database, that skeleton structure exists. I mean, how do we want to create a database? What the information should look like? How, what amount of memory would be stored in that database? That all information is present in this schema. Now, there are two different schemas. One is physical schema, one is logical schema. In simple terms, if I want to give you an idea, the one who are working in any specific data field or when you're working in any information technology or technical industry, you will come across three different schemas. One is development schema, one is test schema, and one is production schema. Now, the basic difference between three schemas is one who is working in any specific environment. You can call it as environment also. If you're working on any specific development perspective, you can use this dev schema. If you're working in testing perspective, you can use this testing schema. And if you're working, your data is completely developed and tested and you want to move it to the production, you can use this production schema. Now, for every process, there is a background skeleton. Now, that skeleton plays an important role. Why? Because the skeleton defines what amount of memory would be stored, how the memory would be stored, and how can we interact, how can we create a database depending on the skeleton format, the background skeleton which we have created. Now, I've given you an idea. There are two different schemas. Now, these are types of schemas. Dev schema, test schema, prod schema, these are all types of schemas. But usually The category in which the schemas are divided, that are called as physical and logical schemas. Now, physical schema means it defines how data will be stored. There is a definition how the data, I mean, what all data would be stored, how the data would be stored. That is called as physical schema. Now, many of you will have a confusion what exactly means a schema. In simple terms, any human body has a skeleton behind it. Now, on that skeleton only, our complete body posture, our complete body structure is dependent on. Similarly, for every database, in simple terms, there is a background skeleton structure, which is called as schema. Now, broadly classified into two different categories, which is physical schema, and physical schema determines where and how the data would be stored. Where and how the data would be stored. Now, second one is logical schema. Logical schema means once the database is created, if you're trying to store that any specific information, either it is stored in table, either it is stored in views, or either it is stored in some other integrity constraints. Now, what do you mean by constraints? That we would be seeing in further SQL sessions. But for now, the information is stored in tables, information is stored in views, or information is stored in integrity constraints. Logical schema will decide how the information would be stored, but physical schema would be defined where the information would be stored. Now, this is how, but this is more probably where the information would be stored. Exact storage location is determined by physical database schema, and logically how the information is stored. That is whether it's in a table format, whether it's in a temporary view format, and whether it's in a integrity constraints format. Now, constraints means there is an interrelation between multiple tables. Now, that relationship can be defined with the help of constraints. Now, that constraints are called as key constraints. Once we move to the advanced concepts of SQL, we would be covering all the constraints related to SQL. Broadly, schema doesn't get confused. I mean, don't get confused. If you get any specific question in interview, what do you mean by schema? Simply answer him and give him an idea, just like our human body, which is dependent on the skeleton structure. Similarly, every database is dependent on the background skeleton structure, which is nothing but schema. Now, you don't have to specifically mention that there is a physical schema, there is a logical schema. Even if you mention the skeleton structure, and if you try to give an example of dev schema, test schema, and prod schema, which is more than enough for any specific entry-level interviews. Now, schemas are asked in entry-level interviews also. Now, moving further, we would be seeing what do you mean by SQL. Till now, we have seen what do you mean by database, what are the features of a database, what do you mean by schemas in database. But at the start, I've given you an idea. In order to interact with database, we need to learn certain programming language. Now, that programming language is called as structured query language. Now, why SQL? Why not other programming languages? We have a comparison here why SQL is important. Now you can see we can also interact with database with the help of Python. We can also interact with database with the help of R language. We can also interact database with the help of Hadoop with the help of Spark. Now this is Spark. Spark is also a programming language which can be used to connect any specific database and make connections as well as interact with the database. Now, out of these five, SQL is king here. And this was introduced in 1970. SQL was introduced in 1970. Since last 55 years, it is still dominating the market of data field. Now, why SQL is important? With the introduction of SQL in 1970s, how is it different that we are going to see? If I come back, SQL is the fastest and easy way to query language for any data related aspects. If you want to communicate with any specific database, data mart, data warehouses, SQL is the fastest and easiest way to connect, interact, and make any specific changes. Used to communicate with the database, as I've said, it is used to communicate. SQL can execute. Execute means it can create or it can interact with the database. It can retrieve. Executing means it is trying to connecting. Retrieving means it is trying to pulling the data from that database. trying to show what all information is present. We can insert, we can update, we can delete. Insert, update, delete, execute, as well as retrieve the information present in any specific database. Now, with the help of SQL, you can do all this stuff. SQL, there are few standard processes which the IT industry follows. Now, that standard processes are, there are few organizations. Now, the International Organization for Standardization, the SQL became ISO certified in 1987, and it became an ANSI certified in 1986. Now you'll have a question that it was introduced in 1970. How come it was, how come it was standardized in 1986 and 1987 only? Now the important point here to consider is, even though it was introduced in 1970, these organizations were considering some other programming languages which were market leaders that time. Maybe in 1970s or 80s, there were some other programming languages which were used to which were used to connect, which were used to interact with the database. But SQL officially became standardized in 1980s or 1990s only. For the first 20 years, it was working as a standalone language which wasn't standardized. You have a flexibility to use, but most probably once you get any specific language or once you get any specific technical aspect standardized by these two organizations, they are more widely used, because these organizations kind of try to make complete scenario. They'll try to analyze what SQL is, why is it so useful, how is it comparatively different than all other programming languages, so that all research they prepare, they'll try to understand the scenario, and then they give their certification that you are certified by ISO, you are certified by ANSI. Now, moving further, we have seen there are different languages. Now, if I give you a brief history of SQL, it was first developed by IBM computers. This first programming language, the concept of SQL, it was first introduced by IBM computers in 1970s. For almost 20-25 years, it was internally restricted to few certain organizations, more probably the IBM internal perspective only. Now, many don't know that this SQL was introduced by IBM. IBM was the first company who introduced SQL. IBM was the first company who introduced the memory cards, who introduced the storage devices also. It was initially developed by these two gentlemen, the Donald Chamberlain and Raymond Boyce. So these two folks who were part of IBM team, who were part of IBM computer scientist team, they introduced in 1970s. They have developed this complete structured query language concept. Usually this is called as SQL. SQL doesn't mean only SQL. It is in long term, it is called as SQL, SEQUEL. They have removed these three vowels, E, U, E. This E, this U, and this E. They have only kept SQL, Structured Query Language. So this is how the renaming was done, introduced in 1970s by internal IBM computer scientists. These two folks, the gentlemen who have developed the SQL, the concept of programming language to interact with any specific database. Now, moving further, once we get into SQL, which is nothing but a interactive language, once you are into SQL, there are different ways of processing the data or a database. Now, ways of processing means the data is changing. In order to continue, in order to match that change, how do we process data? How do we store that data? There are two different ways of processing that data. Now, that two different ways are, one is OLTP, one is OLAP. OLTP is nothing but online transactional processing. Now, this is also called as online transaction or online transactional processing, and OLAP, online analytical processing. Now, in simple terms, if I give you an example, if you're considering any storage device, let's consider pen drive, let's consider your hard disk, let's consider your memory card. These are all storage devices. Now, assume these storage devices are like databases. You can assume pen drive as one database, hard disk as one database, memory card as one database. So we have multiple options also. If you go with pen drive, we can use or we can get SanDisk pen drive. We can get Kingston pen drive. These are all manufacturers of pen drives. Every company or every different company manufacture different pen drives with their own production, with their own branding. Even with hard disk, you will get Western Digital, you will get Seagate. These are all companies which manufacture hard disk. If you go with memory card also, again, SanDisk, Kingston, Samsung, there are different memory card manufacturers. Now you can take this as an example. These are all databases: hard disk, pen drive, and memory card. Now similarly, if you compare it with the real-time environment, there are multiple databases available. Now database is nothing but a background system, but in order to connect, in order to use that database, there are multiple different vendors, there are multiple different manufacturers. Now MySQL is owned by Apache team. PL/SQL, it is most probably owned by the Oracle team. T-SQL, it is owned by Microsoft folks, which is nothing but SQL Server. PostgreSQL, it is a different environment, which is also owned by some different team. So there are different environments. There are different vendors to interact with any specific database with the help of structured query language. Every database uses SQL. MySQL also uses SQL, PL/SQL also uses SQL, T-SQL also uses SQL, and PostgreSQL also uses SQL. These are different ways to interact database. Why? Because everyone is a different vendor. There are very few changes among every database, among every vendor programming languages. MySQL is a different. There is slight difference between MySQL and PL/SQL. There is slight difference between PL/SQL and T-SQL, and there is a very slight difference between T-SQL and PostgreSQL. So these are different ways to communicate database. Language is same, but way of processing is slightly different. Why? Because every language is developed by multiple vendors. Now, what exactly do you mean by OLTP? What exactly do you mean by OLAP? If I take an example of OLTP, the best example is the movement of your money. The movement is transfer of money from one account to different account. If you're trying to transfer certain amount from this person A's account to person B account, he's trying to transfer certain amount. Now that certain transfer amount means he's trying to transfer 5,000 from his account, 5K from person A to 5K to person B. Now for that specific transfer, there is a movement. There is a change in balance also, and there is a change in here the person B's balance. Why? Because this 5K is added from person A account. Pradeep, you have raised your hand. Any specific question to OLTP?
Yes. So you said RD, like OLTP comes under RDBMS. Like what does R stands in RDBMS? Yeah, RDBMS, like database management systems.
Okay,
What does R stands for?
okay. I'll
Because I just got confused a bit of in between
I'll
this
get
thing.
to this. We are focusing on OLTP now. Once this
Yeah.
is done, I'll get to this. What do you mean by RDBMS?
I know database management systems, but I don't know what R stands for. So I was just trying to connect with PL/SQL and MySQL. So yeah. So
Okay. I'll get back to this. I'll also get back to the what do you mean by PL/SQL? What do you mean by T-SQL? But I've given you an idea. These are different vendors
yeah.
and ways to connect the database, ways of
Okay.
approaching the database. I'll get back to the RDBMS also. Um, so coming back to OLTP, if you're trying to transfer an amount, there is a movement of data from A to person B. Now there is a subtraction here. He's trying to transfer 5,000. So at certain time, if he has transferred, this balance would be updated to 5,000 and person B's balance would be updated to 10,000. Now that processing of information is called as, there is a transaction going on between these two people. Now that transaction is called as online transactional processing. Now in simple terms, OLTP means wherever the information is updated on frequent basis, or wherever the information is updated on real-time scenarios or real-time execution. There are large number of databases where the information is updated on frequent basis. Now that specific information is called as OLTP. There are multiple examples. If I take many such examples, if you go to ATM, you're trying to withdraw any specific amount. Once you withdraw that amount, your balance would be updated. Now, certain times the balance would be updated after 5 minutes. Certain times the balance would be updated after 10 minutes. Now, if there is a probability that balance would be updated after 1 hour, that would be a wrong scenario. Now, why wrong scenario? If you have withdrawn certain amount and after 1 hour your balance is getting updated, it's a kind of drawback or a kind of loophole there. Now for OLTP, the most important aspect is it needs to be updated within that specific time interval. If it takes time, then there is certain drawback, there is certain downtime, there is certain, you could say, if the information is not updated on frequent basis of the, or maybe within that time interval, that is of no use. Now, wherever you go, wherever the information is updated within that specific time interval, that all examples are part of OLTP transactions or OLTP, the online transactional processing. If you take a ticket, take any ticket, ticketing system. If you're trying to book a ticket for any specific bus and there are multiple seats allotted here, the seat 1, there's a seat 2 and seat 3. You have booked this seat, the seat 1. And once you make a payment, this seat needs to be blocked. If this seat is not blocked, some other person will come and book this seat. So there is no point. The person A who has already booked that seat, if that seat is not blocked and some other person is trying to come and book that seat, there is no point of using, or there is no point of taking the amount from the person A. Why? Because he has already paid and booked that seat. So wherever the information needs to be updated within that specific time interval, that all examples are part of online transactional processing. If you take online shopping also, once you purchase any specific product, now assume that you're trying to purchase an iPhone. You're trying to purchase an Apple iPhone and there are only 10 left in stock. There are only 10 left in stock and 50 people have logged in. Out of 50 people, 10 lucky people would get this iPhone booked in the specific time. And once that 10 transactions are done, it should show out of stock. But if it is not showing out of stock and the other 40 people are also trying to make a payment, but at the end they'll get to know that the product is out of stock, it is of no use. Once they add it to cart, then only they should get the idea that the product is already out of stock. Why? Because the other 10 folks have already purchased this product. So the updation of information in any specific time interval is most important factor. Now for that specific time interval updates, that are nothing but transactional processing. For every transaction, the information needs to be updated within that time frame. Now coming back, what do you mean by RDBMS? Someone has already shared R relates to relational. R relates to relational database. Now, what do you mean by relational? Relational means there is a relationship between multiple tables present in any specific database. Now, what do you mean by relational? How do we create relations? Once we move to the use case of SQL, there we would be seeing the relation between multiple tables, relation between multiple views also. Now, if you take an example of every OLTP system is a relational database. Why? Because there is a relation between every entity. Now, what do you mean by relation? I'll give you in simple terms. There is a data, there is a database or there is a table where the information is stored for these two folks. These two folks are a part of certain banking system, person A and person B, and there is a database or there is a table where the information, where their balance information is stored. Now, balance information can be stored in multiple tables also. Now, what do you mean by multiple table? Table A, or I'll keep it as table 1. This is table 1. Let me make it more simplify. Now, this is table 1 and this is table 2. This is T1. This is T2. Now, T1 table contains all his personal details, all his address, what is his account number. All these details are present in table 1. The account holder details, not his banking amount, not his transactional details. Whereas table 2 contains all the transactional details. Table 2 contains all the transactional details, what amount is present in his account, what all his previous transactions are. All that information is present in table 2. Now, certainly there has to be a relationship between table 1 and table 2. You cannot create two different tables and you cannot use two different tables separately. There has to be some relationship. Why? Because in table 1, if a person A has an account number, certain account number, that account number is associated and there is certain balance present in that account number. Now, how do you communicate that specific amount or that specific balance belongs to person A or person B? There has to be certain relationship. Now, that relationship can be created with the help of the account number, with the help of unique customer ID given to that specific customer. Now, that specific relation is called as RDBMS, which is nothing but Relational Database Management System. In every OLTP system, there is a relationship between multiple tables which are part of database. That relations, that kind of interactiveness is called as Relational Database Management System. Now, once we move to advanced concept, or once we move to use case of the exact use case of SQL, there we would see in depth. But in simple terms, wherever there is a relationship between multiple tables where different information is stored, that specific database management system is called as Relational Database Management System. Now, if I move to OLAP, what do you mean by online analytical processing, which is nothing but OLAP? Now, let us take an example. If many of you are using this Zomato. So once you go to a Zomato application and you're trying to add any specific food item to cart, just add a food item to cart. Don't try to buy it. Don't try to make a payment. Once you add that and once you come back, you're not ordering that any specific food item. Maybe after 5 minutes, you'll get a notification from Zomato that, hey, we have got a certain discount. You're trying to book certain biryani. You're trying to book certain pizza. You're trying to book certain any food item. Why don't you add it? We'll give you certain discount. There is certain offer going on. Now, this all specific information which we get after 5 minutes is called as analytics. Now, what do you mean by analytics? Wherever your information is collected, whatever what processes you are doing, you have added that food item to cart but you are unable to purchase, that Zomato will detect, that any specific backend application will detect that certain product is added to the cart but he is unable to make that payment, or is not moving it to the ordering it, or he's not moving it to the end process, not ordering it or not making the payment. Now, in order to give certain interactive or maybe to get certain product ordered, to get certain food ordered, they'll give you certain offers. Now you can see there are 50% off. There are multiple notifications you get. Even if you're not ordering from Zomato, you are a frequent user, you are a frequent person who is ordering from Zomato, and you take a gap of 2 days. Within that 2 days, you will get multiple notifications. What happened? You are not satisfied with our service. We are giving you certain off. We are giving you certain discount. So all this information is collected from Zomato's backend processing team. They'll try to analyze your previous history and they'll send a notification that why don't you order a food product? Why don't you order this food at this specific time. Now that analysis of data, going back, getting the historical information analyzed and processing that any specific offer, giving certain discounts, that information is called as online analytical processing. In simple terms, analyzing your historical data and giving you suggestions. OLTP is nothing but updating it on frequent basis. If there is any certain change, if there is any movement of information that needs to be updated within that time bracket. But OLAP, whatever has been done in the past, previous time, whatever has been done in the past, with that, they try to get information, they try to analyze your information, and they'll give you certain suggestions. Now that suggestions are called as online analytical processing. Difference between OLTP and OLAP is OLTP is updated within that time frame. It is very quick. OLAP, all the historical data, processing of all the historical data is called as OLAP. The basic difference, it is online transactional system. It is online data retrieving or data analytical system. Now, in simple terms, OLTP is categorized by a large number of short transactions. Now, large number of short transactions means if there is a balance change, now there might be multiple, there might be thousands of people who are using a specific ATM, who are using a specific banking, the net banking platform. Now, there could be multiple entries there, but that entries are multiple, large number of entries, but short online transactions. If you compare it with OLAP, there can be multiple large amount of data which can be analyzed, and depending on that, they'll give you suggestions. For net banking also, OLAP plays an important role. If you are using a credit card, or maybe if you are using a net banking on frequent basis, and once you off that net banking for few days, in that application also you will get certain notifications. It's been long, we haven't seen you. Why don't you make a small transaction? Why don't you make a small online transaction? Now, what they're doing, any banking platform, they're going back, they're trying to analyze your historical information, which is present in large amount. Once they analyze, they'll send a notification. Now, OLTP is nothing but instantly transferring the amount. Within that time frame you're transferring and the information is changed. Whereas OLAP, all the historical data is analyzed and then coming with certain suggestions. OLTP uses DBMS, OLAP uses data warehouse. Now, somewhere we'll connect the dots. At the start, I've given you an idea. DBMS, which doesn't mean by, which means by database management system, and data warehouse, where all the structured data, historical data is present. DBMS can be of 10 GB. DBMS can be of 1 TB. There is certain limit for database management system. But for a data warehouse can be of 100 TB. Data warehouse can be of 100 petabytes also. That is how vast data warehouse is. All the historical data is stored in the data warehouse, whereas in database, current information which is updated on frequent basis, that information is stored in OLTP, which is nothing but current database management system. Whereas OLAP, all the information, historical information, it could be in it could be in 100 petabytes also. Historical data, large in number. OLTP, insert, update, and delete. You need to insert, you need to update, you need to delete. Whereas OLAP, it mostly uses select. Now, why only select? In OLAP, we are not updating any information. It is previously updated. It's a historical information. So Mohit has a question, will the data be deleted frequently from data warehouse or DBMS? Now, what I'm trying to explain, it will answer your the question. Insert, update, and delete. If the information is changing frequently, their OLTP we are using. Now, that change of information, if a certain person has closed his account, closed his net banking, or closed his account with any specific banking or any specific bank, his details need to be updated. Why? Because he might use his credit card, he might use his debit card even after he's closing his account. Now, in order to update that, the bank has to delete that specific information from the banking software. Now that delete happens on instant basis within that time interval. Whereas if you compare it with OLAP, his historical information can be stored. If that specific person is coming back again after 2 years that I want to open an account, I previously held an account. So what they will do, they will go back and search his details. His account is already closed, but his personal details are present in the background, in the historical information. Now getting that historical information is nothing but selecting some information. We are not updating, we are not deleting that person information. We are only going back and selecting. We're trying to see if that person if that person was he had a bank account with us or not in the previous maybe 2 years back or maybe 3 years back. We are only selecting that information. Now that selection is called as online analytical processing, whereas deleting at that specific time interval is called as online transactional processing. OLTP, very fast, very quick within that time frame. OLAP, it's a historical data. We only use select. We only retrieve the information. We are not updating, we are not deleting, neither we are inserting. Now, if you take the time period, OLTP response time is in milliseconds. In OLAP, response time is in seconds or probably minutes. Sometimes OLAP takes in hours also, but most of the times it takes minutes, certain minutes to get the information analyzed and get back, retrieve that information. Whereas OLTP, we are doing it on within the time interval. We are deleting a certain account. We are updating the information from account A to account B. That has to be done in within millisecond. So OLTP is way more faster if you compare it with OLAP. Why? Because OLAP has all the historical information. That clears your question, I guess, Mohit. So I have two who have raised the hands. Give me 5 more minutes. I'll be closing this. Then we can go ahead with your questions. Now, at the end, somewhere I've given you an idea. There are two different aspects. There are two different ways. One is NoSQL and one is SQL. In SQL, we know the information is stored in the structured format. In NoSQL, the information is not stored in the structured format. No, structured format means database, structured format means table. Whereas NoSQL means there is no table, no tabular information. It is stored randomly. It is stored wherever it wants. Now, what are the differences between SQL and NoSQL? SQL stands for structured query language. NoSQL means not structured query language. Now, I've given you an idea. In OLTP, we uses RDBMS. RDBMS means there is a relationship between multiple tables used in that database. In case of NoSQL, the information is not stored in the structured format. It is randomly stored. So that randomly stored information, we cannot create a relationship. It is non-relational database management system. Now, these are all advanced concepts. Data is stored in table with row and columns. Data is stored in collections or documents. Now, this is an important concept, collections or documents. If a certain person is coming and trying to share information in an Excel format or maybe a CSV format, now that all CSV files are dumped into NoSQL. Whereas if you want to collect it into a structured format, you need to have a table. From that Excel, from that CSV file, you have to dump that information to certain table where the structure of that information is already created. The skeleton of that information is already created in the background. In case of NoSQL, you can directly dump because there aren't any tables. There aren't any relationships. Suitable for structured as well as predefined schemas. As I've said, for every information you insert in SQL, you need to have a skeleton behind it. You need to have a predefined schema. NoSQL, it is usually used for semi-structured or unstructured data. Now, these concepts are high-level concepts, acidic properties, joins, normalized data structure. But the best examples of SQL are anything where the SQL is used. MySQL, PostgreSQL, Oracle, SQL Server, Microsoft SQL Server, all these tools are structured query languaging tools. Whereas if you have come across these concepts, there is a MongoDB, which is vastly used NoSQL service. There's a Cassandra. This is also a NoSQL database. Amazon Dynamic DB. This is also a NoSQL database. In Azure format or in Microsoft format, we have a NoSQL database called as Cosmos DB. Cosmos DB is also a NoSQL DB. This is most widely used NoSQL database from the Microsoft point of perspective, from the Azure point of perspective. Now in NoSQL, information is directly dumped. There isn't any structure. That is the only difference between SQL and NoSQL. Now, where do we use NoSQL? What is the importance of NoSQL? That we would be seeing in advanced lecture. But in simple terms, most of the data analytical related properties always come from SQL, always come from structured query language. We rarely use NoSQL concept. We rarely use NoSQL concept. Data warehouse is also a SQL concept, because in data warehouse, previously stored information, the historical information is dumped. Now that historical information was somewhere a real-time information earlier. Now that real-time information was stored in SQL. Once that information is kind of went back, or maybe if you're trying to focus on 2010, which is an historical data. If you're trying to focus on 2020, it's an historical data. If you're trying to focus on 2023, it's a real time, it's a current scenario. So current scenario would be stored in OLTP. The historical scenario would be stored in OLAP. Both are part and parcel of SQL, not NoSQL. NoSQL is completely different. It is rarely used from the data analyst point of perspective. Yes, if you are an architect, if you want to dump information without creating any specific skeleton, without creating any specific table, there you can go with NoSQL. Now, where do we use it? In real time, I'll give you somewhere an idea in between SQL lectures. If I give insights here, it would be confusing. So simply focus on SQL. Most of the times, 99% of the times, we always go with the structured query language. Yes, Pradeep, you can go ahead with your question.
Sorry, I don't have any question.
Okay, I thought, I mean, you raised an hand.
Oh.
Yep. So we kind of covered SQL and NoSQL differences also. We kind of covered the difference between OLTP and OLAP. These are two ways of processing the data in a specific database where the information is stored in the tabular format, the table format. Tabular means table format. And we have also seen how do we interact with any specific database. SQL is a programming language which is easily understand, which is faster than all other data programming languages. Python is also faster, but if you compare Java and Python, Python is way more faster. Why? Because Java, we need to declare multiple strings, we need to declare multiple input and output variables, input and output concepts there. Whereas in case of Python, you don't have to declare all this. Once you make a declaration, you can use it for n number of files. In Java, for every file, you have to declare different input and output variables. If the Java code is of 10 lines, Python code can be written in 2 lines or 3 lines. But if you compare SQL and Python, SQL is different. Java is different. Java is a interactive language with a website. You can create a website, you can create a backend process. But in order to create a database, you need to learn Python, you need to learn SQL. But if you compare Python and SQL, SQL is way more faster than Python. Certain scenarios we use Python, but very rare. 60 or 70% of the time, SQL concepts are used to interact with any specific database. Yes, Julie, you can go ahead with your question.
Hi, I have like a couple of questions. The first one is, so since like you were talking about when the data becomes historical, they move to data warehouse, right? From the RDBMS system. So is there like a industry standard or is there like a normal standard that we should know, like how long based on the industry or
Yep.
like how
I got your question. I got your question. So it's completely up to the client or the person whom we are working with. Now let's take an example of Microsoft, to whom or the the team which I'm working with. In case of Microsoft, they'll always focus on the current financial year. Now, for Indian point of perspective, financial year is from 1st of April to 30th of March. And from the US point of perspective, from 1st of July to 30th of June. So they'll always focus on the current year, current financial year, which they assume as a OLTP, that is current system or real-time information. Whereas anything prior to that always goes with OLAP, historical information. Now, this is simply an example depending on your client. There are some clients which they assume that the last 3 years data is OLTP and prior to that it is OLAP. That answers?
Yes, thank you. One more question. So the MongoDB and Cosmos DB, you were talking about the NoSQL concept, right? So,
Yes.
so that's very much different from Hadoop and Hive and all that, right?
See, in case of now you're trying to speak about Hadoop. Hadoop is a big data.
Because you did not put Hadoop and stuff in the example of SQL.
Yep.
So you just put the SQL languages.
See,
So
somewhere I've given you an idea. Hadoop is a combination of you could say the information which is stored in Hadoop. It is mostly 80% structured, 20% unstructured. Now, what do you mean by unstructured? Unstructured doesn't mean it is no SQL here. In case of Hadoop, Hadoop is used for big data. You might also know that Hadoop is used for any big data platform. Hive is also a kind of interactive with the big data platform. It's a kind of programming language where big data information is kind of connected and interacted. So these two concepts, Hadoop and Hive, most of the time, 80% of the information is structured, 20% is unstructured. Now, why unstructured? Because data is present in very, very large format or very, very huge format. So in such cases, we always go with SQL only, not NoSQL. Now you have a confusion that where do we use NoSQL? Yeah. So in case of NoSQL, if a certain person is unaware what information we are trying to get from the end user, in such cases, you can always go with NoSQL database. In simple terms, if I wanted to give you a simple highlight, there is a client requirement that he has requested to create a database. So the information in the database would be coming from multiple people around the world, but that client is also unsure. That client is also unaware that how the information would be coming. Now, in such cases, you can create a NoSQL database and you can get all that information. Once you get that information, you can analyze that and you can store it in the structured format.
Okay. So, and one more thing. So in Hadoop, you said like there's 20% of data which is not structured. So for that 20%, do they use like something like a NoSQL?
No, they will never go with NoSQL.
Okay.
They'll always go with the structured query language only. But in case of big data, certainly in big data, the processing time is kind of slower as compared to the SQL format. So in order to improve that process, they are coming up with different programming languages. Hadoop and Hive were historical. Now, most of the people are moving out from Hadoop and Hive to Spark. Spark is way more faster.
Okay. Sorry, one final question again.
Yeah.
So since like OLAP is more of analytical, is it like and OLTP is most of live projects. Will that OLAP be like not like an agile project, or everything is a...
No, both are part of agile project. So if I simplify it, in OLTP, I mean most of the projects focus on the last 1 year of data, and that last 1 year of data can be accumulated in a relational database management system. So they'll always go with OLTP, but you have to always analyze the historical trend also, because the information is somewhere stored in the warehouse. Now, in such cases, nowadays they are going with Spark technology. It is a part of agile system only. I mean, wherever you work, even if you're working with NoSQL, it is a part of agile system. So agile is a different concept. It is way of working in any organization, way of working in any project. Any more question?
That's it from me. Thank you.
Okay. Yeah, Pradeep, I guess you have a question now.
Yeah, I'm sorry. Adding to what she has actually asked, I'm just confused. Like, does like the analytical processing, like the OLAP, the online analytical processing, does because you mentioned that OLAP is a storage system where the data is stored from stored from warehouse, and it uses like Hadoop, Hive, and Spark. So does this means like the OLAP comes under NoSQL?
No, it always comes under SQL only. See, historical data means, see, if the organization has started its the vendor market presence or its market presence in year 2000, and we are in the 2023. So from past 23 years, that specific organization might have generated the data. So they would be always focusing on the last 1 year, the last financial year, or the current financial year they are working in. But anything prior to that, all would be the historical information. So in simple terms, last financial year information would be some 10,000 records, or maybe some 10,000 rows, or maybe 1 lakh records. But in historical information, every year they might have generated 1,000, maybe starting in 2001 it would be 1,000, in 2010 it would be 10,000, or maybe in 2020 it would be 20,000. So this will accumulate around 10 lakhs or maybe 5 lakhs of information. So in order to process 1 lakh information, it will take less time. In order to process historical, which is of last 20 years, of 5 lakhs or maybe 10 lakhs information, it will take some more time. So in order to make sure, in order to get that data very precisely, you cannot use SQL concept there. I mean, you cannot use T-SQL, you cannot use PL-SQL. You have to always go with some different language. Now that some different language is called as Spark language, some different language is called as Hadoop language. It is still a structured language, not a NoSQL language.
Okay, now it makes sense. So I think, like as you said, it takes more time compared to like the Spark, Hadoop,
Yes.
or Hive to process the database. It takes more time because the data is of large quantity, like or in large volumes compared to OLTP, where the like online transaction processing will have a minimal amount of data, which is structured in time to time manner. Am I
Yep.
correct?
Yep.
Okay.
Any more questions? Now we are yet to reach the how do we install database? How do we connect that database? So probably we'll be doing that on Monday. So today is Friday. We have our sessions from Monday to Friday, a gap of Saturday and Sunday on weekends. So let's connect back on Monday. Course duration, Mohit, it is of 4 months or 80 days. Now 4 months would be 120 days, but Saturdays and Sundays we are skipping. So 80 days of lectures, and cost of this course is 30K. If you want any additional information, let me, Mahesh, are you there in the call? Okay. Let me get Mahesh. He'll give you certain insights. How do we, I guess he's already shown you, but again, he'll try to show you how do we enroll for this course. And if you want to connect with the KSR team, in the chat, I'll mention the numbers, or what I'll do is I'll go to the first slide. There the contact information is present. Yep. This is the first slide. If you want to connect with the team, this is the contact. Is there any weekend classes? Sorry, Mohit, I guess KSR won't have any weekend classes. Why? Because every instructor here is a working professional. So on weekends, they also take an off.
Sorry, I have one more doubt.
Yeah, Julie, I can go ahead. Go ahead.
So in the physical DB schema, so just wanted to know if my understanding is right. It's like a preparation of where the data is, like a document or something, like where the data is stored and information like that in a document. Is it right?
Yes. Now, if I want to simplify it, if you're trying to construct any house, you'll first design a layout. and you'll try to create where the living room would be, where the drawing room would be, where our kitchen would be. So that is physical schema. And how do we construct it? I mean, what would be the structure of the drawing room? How long it should be? What should be length and breadth? That is logical schema. Any more questions?